Hello, my name is Pratyush Chera, and today I'll be presenting my journal discussion on the increased tumor homing and tissue penetration of the filamentous plant virus nanoparticle potato virus X. Before I begin, I'd like to give a rough outline of nanoparticles. So, nanoparticles are a tool that we can utilize in drug delivery to deliver the drug to specified regions, particularly tumorous regions, by coating these nanoparticles in a biocompatible layer, like PEG, and then covering them in targeting ligands that bring them to the tumorous region and ensure they attach before releasing their drug load. One of the focuses within drug delivery research is on the shapes that might benefit the nanoparticles infiltration into the tumor region. The most common shapes discussed are spheres and rods, and recent research has shown that the rod shape may provide superior infiltration if you can find an efficient way to make it biocompatible, as one of the limitations of this structure is that the most simple and straightforward way to make a structure in the shape of a rod is to utilize a carbon nanotube, which has limited biocompatibility. The purpose of this paper is to investigate whether cowpea mosaic virus, CPMV, or the potato virus, PVX, might make a good biological mirror to these two shapes to directly compare their infiltration into tumor sites in biological models. Now, as I stated before, the objective of this study is to show that the shape of the virus affects its uptake into tumors, and that these results should ideally mirror initial experimentation that shows that the rod shape has better infiltration in synthetic models. If this can be achieved, this opens the avenue for new biological delivery systems. Now, first, each viral agent was cultured within its respective preferred host and then purified in order to achieve a sample for each virus. These viral agents were then tagged with a tracing agent, a fluorescent in this case, and then coated in PEG in order to increase biocompatibility. These samples were then inserted into xenograft models, avian embryos, as well as murine models, utilizing human tumor cells. After a 4-hour period of exposure, the tumor regions were excised from their host, and then fluorescent imaging was utilized to determine the concentration of the virus within each tumor type. So, initial results comparing CPMV versus PVX in the avian model showed that PVX's uptake into the tumor core was superior to CPMV, though they were identical across the entirety of the tumor. When looking at the murine model, we see that the PVX shows higher concentration in the murine model in comparison to the CPMV, as can be seen both in the A647 signaling as well as in the fluorescent signaling at the bottom. Another focus of interest was in which of these agents were retained within the tumor cell over a longer period of time. And here we can see that both the initial concentration of the PVX was superior, as well as the amount of time that it took to drop below 1,000, with the CPMV not even beginning there. Though it should be noted that the overall half-life of the CPMV was slightly longer than that of PVX. Finally, when evaluating which parts of the organ system the virus agents found most commonly was in the spleen and liver, which is reasonable as these two organs are primarily designed to filter our blood for harmful potential agents. We see that the PVX is more common in the spleen, whereas the CPMV is more common in the liver. However, when investigating which one managed to get past these barriers and infiltrate the tumor, we see that the PVX is still most commonly found within the tumor in comparison to the CPMV. These results would indicate that the PVX is a better infiltrator and better at remaining in the target tumor site. It also indicates that its structure is better suited for potential drug delivery, and these results also emulate initial experiments using artificial nanoparticles of each respective shape. This, in turn, provides a future avenue for the structural design of nanoparticles, as well as a potential biological nanoparticle in contrast to synthetic ones. Thank you for your time.